Okay, hello guys. We're going to now work on the last set of multiple choice problems starting from number 40, and these are, well, some are crazy word problems and others are, well, this number 40 is basically an arbitrary triangle. I'm going to just draw and label triangle and see what I have. I have, I'll label angle A, B, and C. Remember, capital letters and opposite sides are the lowercase. And make sure that the lowercase letter is always opposite the uppercase angle. And I'm going to just fill in the blanks as far as what the angles are. And this side here is 12.1 inches. And the side C is 7.4 inches. And we had the special rule that if you had side angle side for any triangle, that the area is always equal to 1/2. And I think the equation was like actually it was like K is equal to 1/2, and it went the well, this side B, side C, and then the sine of the included angle A, and that would work for us for this setup. So it's going to be 1/2 7.4 times 12.1 and times the sine of 22.9 degrees. And when you plug that into the calculator, you get an area of 17.4 inches squared, and they asked for the nearest whole number, so 17 is my answer. Remember, if this was a square and the angle was 90, the highest the value could be for this would be 7.4 times 12.1. So just to give you an idea that the answer shouldn't really be beyond 84 square inches, just as a point of interest. So now we have, our next problem is some vector math. We have a boat sailing for 5 hours at 30 miles per hour in a direction of 106 degrees 54 minutes. So this is a compass heading. So here's the boat. It starts, remember, north is always 0 degrees, and 106 degrees would be a little bit south of the east heading. So remember, east is at 90, so 106 degrees is a little bit less than that, or a little bit below that, and this would be 106 degrees 54 minutes. So now you want to figure out if it traveled for 5 hours at 30 miles per hour, we know it went 150 miles. We want to now resolve this into a triangle that has how far south did it sail. So we want to find out this side. This is a 9-degree angle, and this angle here is 16 degrees 54 minutes because of the original heading of 106.54. So now I'm going to use right triangle trig, and I'm going to consider using the sine ratio. The sine of 16 degrees 54 minutes is equal to x divided by 150. So I cross multiply, and I'll get my answer. And the answer for that is 43.6 miles. And so we'll choose, because it's the nearest mile, 44 miles. The next problem is very similar. It uses a compass heading of 309 degrees and a rate of 170 kilometers per hour. So it takes off from St. Louis. So we'll just say St. Louis, and the plane will take off compass heading of 309 degrees. So this is north, and a 309 degree compass heading would bring you around to facing the northwest. And so remember that as we look at our compass, that this is 90 degrees, this is 180 degrees compass headings. So this is 270 degrees, and this angle here to get to 309, this would have to be 39 degrees. So we'll use our right triangle trig again to figure out the western component of that triangle. And we know that because it was traveling for 2 hours at 170, this is 340 kilometers. So we'll just redraw this triangle. This is 39, this is 340, and this is the side that we're looking for because it wants to know how far to the west of St. Louis the plane has traveled. So that will be the cosine ratio, because this is adjacent, hypotenuse. Cosine of 39 degrees is equal to x over 340, and when we cross multiply and use our calculators, we should get an answer of 264 kilometers, and that would be choice D. The next problem: two tracking stations are on the equator 162 miles apart, and so here we'll just I guess we'll draw the Earth, the equator. So two tracking stations on the equator are 162 miles apart, and a weather balloon located at a bearing of north 43 east from the western station, that would be this one. So the heading is north 43 east. So that angle would be 43 degrees. And the bearing from the eastern station is north 19 east. So I'm going to just redraw this on so that we can see it like this. This is the one bearing, so this angle here is 43 degrees, and this is the other bearing, so that angle in here is only 19. So how can we get, if we know this is 162 degrees, how far is a balloon from the western station? So we're looking for that distance. So what we can do is, we know that this angle here, because 43 plus that angle has to add up to be 90, so that's going to be 47 degrees, and we know this angle here is 19 degrees greater than 90, so that would make this angle 109 degrees. So now we have a situation of angle, side, angle, and we're going to label our drawing as WEB, and these sides will be, the side we're looking for is lowercase e, this is lowercase w, and this side here, which is 162 feet, that would be lowercase b. We compute our other angle B here to be the difference of 109 and 47 from 180. So 180 minus 109 and 47. So that would be 34 degrees. I mean to say 24 degrees. And now we can do law of sine. So the sine of 109 over E is equal to the sine of 24 degrees over 162. Cross multiply. E is going to equal the sine of 109 over the sine of 24 times 162. And E would equal 376 or 377 miles. So that's all the time I have for this part. I'm over 10 minutes already, so I'm going to submit another video to do the remaining problems, 44 through 47. Okay, I hope this helped, and we'll talk to you later.